Zoom, Jitsi, and YouTube, but now it should be live on the YouTube channel as well. All right, so yeah, we've already been talking for a while, but it's nice that today we have Andrea as well. Yeah, so go ahead.
So yeah, I was talking about there's a big difference between using the code and contributing to the code. And in our Geolatinas coding group, we realized that when people started talking about contributing and especially writing scientific papers that are now being accepted in very prestigious journals, and we wanted to sort of begin to understand how to contribute to the codes that we always use. There was a big learning gap, or big learning curve to understand how to start contributing. And we're really grateful that Santi and Agustina stepped in and gave us a tutorial on how to contribute, how to use Git, how to use GitHub. And that has helped a lot for some of the ladies that are looking into contributing. For example, I'm trying to contribute to Harmonica. I made a code. It works. I don't know if the answer is right. So now it's more of like testing the science, like testing the answer more than actual coding. So I'm looking into like books and stuff to understand if the densities that I'm getting make sense.
Okay.
And Mariana is also contributing to one issue. I'm not sure yet. We're going to meet tomorrow to see which one she is. But I think it's great that it's more reaching out to people to do this than is expecting for them to do them themselves. I think that's the biggest learning thing that I've seen.
Yeah, for a long time, I had the really mistaken idea that, well, it's out there, it's public, I'm sharing links to this, and of course, if anyone is interested, they're just gonna come and well, they will learn and they will start contributing. But yeah, no, it doesn't work like that. Of course not. So yeah, so through that, I mean, I did kind of manage to rope in Santiago and Agustina. They were people who just showed up, but yeah, it's really hard. It doesn't scale, and it doesn't really help with diversity if there's this big barrier where, well, you need to have free time, you need to be already looking for this sort of stuff in order to find it. And yeah, so now we're really trying to make like a conscious effort to reach out to people and say, no, well, do you want to give this a shot? We can help you learn Git and that kind of stuff. That's really where there's a big barrier there. Once we can get people submitting a pull request, we can help them with the testing, with the code format, the documentation. But getting to that first pull request is challenging.
It's hard. Yeah. Well, I think, in the GitHub and all of the documentation in the website is amazing. It can't be any clearer. There's no more clearness to how to contribute and how to do the documentation if you're writing the code yourself as well. It's all on paper and on a website. I think a more person feel to it is going to bring more people together to contribute. That's what I feel, that we're behind these screens a lot and looking at documentation, but we can always just talk. That would be great.
Yeah, that's what these calls and the Slack are for, is to try to get this going and actually meet the people behind it.
Okay. That's great. What are the next steps for Fatiando? What are you guys planning to do next?
Right. So, I mean, I think at this point, we have a couple of tools that are pretty advanced. Verde is in a good stage right now, and Pooch is getting some traction. So that's actually not even geophysics specific, but it's just a tool for downloading data, and it started getting adopted by some more notable Python projects. So I don't know if you've used scikit-image, but they recently started using Pooch to do the data download for the documentation. And so whenever when you're using stuff like scikit-learn and things like that, they usually have data sets that they would download and that you could use.
Yeah.
And Pooch kind of manages that part.
That's great.
But I think where we need a big push now is with Harmonica, and Santiago has been leading that. So yeah, the reason why there's anything in Harmonica at all is mostly because of him. and yeah, I think that's the trickier part. That's the one that doesn't have such a narrow scope.
Yeah.
And it's really difficult to plan ahead even. So we're kind of experimenting at the moment with stuff like how do we do the Pratt isostasy stuff. Even there's some open questions in there, right? So how would people use this? What's the best way to do it? And trying to plan for that is really hard. So at this point, I guess we're just hoping to experiment and build some stuff and then see how it works. And if it doesn't, then we change it. That's the beauty of it.
Yeah. I see in Slack that there's many people like just randomly asking like, can Harmonica do this and do that? And so there's people that are engaged. Do you know if these people are in the academia or in the industry?
So I know some of them. So I think who is it? I think Richard. Where is he?
Let's see.
So Richard is in industry, I think, but I'm not entirely sure where he works. I don't remember now. But there's another Leonardo in there who's also from Brazil. He did his PhD at the same time as I did in Rio, and he has his own company. I think there's Dieter as well, who's I think now he's in academia, but he works a lot on EM methods. Martin Bentley is in South Africa. I think he finished his master's now, and he's now working for Agile. So there's a bunch of people from different places. There's academia and industry.
Yeah.
Regarding, sorry, go ahead, Santi.
Yeah, and Lorenzo, I think he's a co-founder of GeoLearn. I think that's a company also.
Mm-hmm.
Yeah.
So there's like contractors, like maybe like startup people that use. So it's more of like they ask you to add certain elements to get more, I guess, to get what they need for their clients or something. And it's more. I'm thinking in the GravMac community, it's in my eyes so small. Maybe because I haven't been out there that much, but I see that it can be used to do PhD thesis, master's thesis, postdocs, and then there's the other side of like contractors who know how to code in Python and want to use open source, and so they need the development of all of these things, which I'm trying to see which group has more reason to contribute. I don't know if that's just a timing issue.
Yeah, I mean, what I would, it depends. I think both groups have incentives, right? So academics, if you're developing new methods in a gravity mag, like the group in Rio, then if there's a lot of stuff that's already implemented, right, they can focus on doing their new inversion instead of doing implementing like the forward modeling for Prism, right? That's it's well known. Like we actually have a really good code for that. I think we probably have some of the best implementations of that because there are just these tiny details, and we found some stuff like Santiago dug up some papers, and I found some stuff from experimentation. And so, for example, there are some caveats to the published equations that if you don't take care when you're implementing, then the solution is valid on top of the prism, but it's not valid on the sides and in the bottom. And I actually only found that because someone was trying to use this to calculate effects inside a borehole. And then they just realized that, oh, no, wait, when I'm calculating on the side of the prisms and in the bottom, it's just getting crazy results. And yeah, it took us quite some time to track down what the problem was with that. It was just some weird arctangent thing with the implementation.
Okay.
But for speaking for harmonica, and this is part of why Fatiando changed a bit from 2018 forward, and why we just restructured the entire project. And it's just because when I started this, there wasn't much out there in terms of geophysics in Python, but now there's a bunch of other packages. Right now there's Simpeg, there's GemPy, there's PyGimli. There's a lot of stuff for seismic. There's SegIO. There's a lot of stuff, and particularly Simpeg and PyGimli, they have like a very particular structure to them, where they're solving a partial differential equation, and then it doesn't really matter which partial differential equation you plug in. The framework is the same. So that's awesome if you're doing joint inversion of gravity and something else. It's awesome if you're doing EM and all that stuff. But what these projects don't cover is, say you want to do like invert for the relief of a basin. You can't do that with their current framework, or you might be able to, but it's not straightforward. Or you can't do. They don't have anything for the data processing and the gridding and the corrections and all of that.
Exactly, and I think that's why Fatiando is so appealing to what I do. I know the developers of Simpeg and Lindsay, and now Joe that went to school with me is going over there to British Columbia and joined.
Oh, cool!
I saw it. I saw Doug Oldenburg present it at Mines, and it was when Jupyter Notebooks was starting out, and I was fascinated. It was so cool. It is a very compelling package, but it's not applied to things like how you said data processing, more real life, maybe not simple, but like the first things you need to do to the data to get a data set that's of quality and processed correctly with the things that you know. So after that, I guess you can do the modeling and the inversions that Simpeg and PyGimli also apply. But this part of getting the raw data to data of good quality is, I think, what you guys are focusing on. And there's nothing out there that does that. I mean, there's Geosoft, but that they don't even do that well. You have to pay for it.
Well, yeah, so that's exactly why we kind of refocused that way, is because that's what I saw. It's like there's no point in trying to replicate what's already in Simpeg and PyGimli, because they do it really well, right? So instead of trying to re-implement everything, well, if we have to do that sort of inversion, we use that, but let's try to fill the gap that's missing. And that initial gap really is missing quite a bit, particularly for gravity. I have very strong opinions about gravity. And for example, there's just absolutely no reason to do free air corrections.
Yeah, I see that.
There's no reason.
I see that.
We have equations that calculate the ellipsoid field at any point. You don't need to calculate it on the ellipsoid and then approximate an upward continuation. that's just ludicrous. The only reason to do that is because the equations are simpler that way. But we have it. We have the code. It's in Bool, which is one of a package that exists pretty much just for that. And as far as I'm aware, that's the only available implementation of these equations anywhere. So that's not on Geosoft. That's not on Intrepid that I know of. So I don't know of any commercial implementation of these equations, and I don't know of any open source ones either. And this equation has been around for decades now.
I'll check Bool with my boss. He started writing code on paper when computers didn't exist, and he's 80 now, and he still codes every day on Fortran, developing stuff for the company. He's a gem for sure to have. I'll make him take a look. He's always been very passionate about. He's a mathematician by trade, so that's very interesting to know that this equation hasn't been implemented. It's just a simpler way of applying a free error correction. In our marine data, we don't worry about that, of course, but it's stuff that people that do very difficult surveys with large topographic reliefs struggle with, and how to like have an even data survey to start off with when you have very large topographic relief. So it's something that's definitely of interest.
Yeah. Another thing I forgot to share. So I just sent on the Jitsi chat. There's a link to shared notes.
Okay.
So everyone can edit this. So if you want to add anything, we keep track of future. So whenever we're done with a call, we'll start a new section where we add stuff over the month for things that we want to talk about. So feel free to add anything, and if you want to add your name there. So let me add mine as well, and then we can just do the notes together.
Great. I'm looking into Bool now, the documentation and what is in it. Yeah, it's very cool. I'm the pull request that I'm going to make is the Pratt isostasy in harmonica, and my question was about how to apply it. In normally what we do is an isostatic correction. So we calculate the gravity response of either the whatever Pratt model or Airy model, and then we remove it from the gravity data that we've observed. And I asked Santi about, is that part of harmonica, or are you guys thinking about doing that?
Okay. The whole idea of the Pratt isostasy function is to return like a grid or scatter of density values. So it wouldn't be computing any gravity field. It just computes the density of the crust beneath the topographic point. So we don't plan to code a specific function to applying correction of the gravity anomaly generated by the isostatic following Pratt's hypothesis, but we do provide the tools to do so. So you can compute the density with the function you're coding, and then you can model that with prisms, for example.
Okay.
And if you want to do so, you can, but we are not trying to write every possible function because that's crazy.
It's very time consuming, yeah.
But sometimes it's good to have functions for to ease some tasks. For example, Lorenzo asked me, as you mentioned, that people ask sometimes stuff on Slack. He asked me about how to do terrain correction. So actually now you can do terrain correction because you can model prisms, and the forward modeling of prisms is right there. You can use it, but building the layer, approximating the terrain with prisms is not very straightforward right now. So I wrote a function to build like a layer of prisms very easily, like pass me a region and pass me the size of the prisms, and the top and bottom layers, boundaries, sorry, and then you get a very nice object that you can manage. You can store that layer into disk if you want to use it later, and then you can compute gravity fields from that. So that's a pull request. That's open pull request. Lorenzo is reviewing it. So that's maybe the whole idea now of Harmonica, is trying to implement stuff that we have use cases for. So because we found ourselves trying to code something that we are not about to use in the short term, and we found very messy design with that. We had to change afterwards because we didn't have any use case for that. We just coded like we could, and probably not with the user in mind. So we always try to, for example, run an example first of how we would use that feature, and then start writing, for example, the documentation of the feature, and at the end we would write the code. It's kind of hard at the beginning because our mindset is always on the code and how to implement this.
Interesting.
But that workflow is put the user first and the user experience first, and the implementation later. So if you have a nice user experience in mind, how do you implement it? It's secondary. And the good stuff is that if you have, for example, you implement some stuff with some user experience in mind, and then the implementation is kind of bad, or you want to improve it, you can do it under the hood without the user even noticing it.
Yeah.
So that's good for software development.
I see that in a lot of softwares that they put out there. I mean, there has to be a balance between a black box and a very messy code. There's things that can be put into the box without you seeing it. But lately I've seen not very user-friendly software where you have to do repeated lines of code, which is useless, because why do you need to repeat the process if you've done it already? That's great. That's a very interesting way of developing. Just first the documentation and the layout, and then the code.
That really helps, because the thing with developing software for other people is that if I change, for example, how I calculate the prism field to make it more efficient, as long as the function name is the same, the parameters are the same, and the return value is the same, then the user doesn't need to do anything in order to upgrade. But if I decide that, no, I want to change the function name, then if the user updates, suddenly their code doesn't work anymore because the function changed names.
Oh, yeah, of course. Yeah.
So the one thing is that it's very easy to change the inside of a function. It's very hard to change the outside part, which is the interface.
Okay.
So by doing the documentation first, we make sure that we have a good interface that hopefully we won't need to change, because changing the interface is hard because it breaks people's code.
Oh, okay. I haven't gotten to the level of how this compiles and lives in people's computer with once. I mean, because I can see it in GitHub and I can see the .py and blah blah blah, but I don't know the technicalities of like compiling and downloading, and then how you can change it with on your end, and how that framework works, the compilation of the code. I haven't gotten there yet.
Yeah.
I don't know anything about that.
That's the big gap that exists between coding and software design. Or software engineering, right? So software engineering is all about that part of how do you distribute code? How do you make sure that everyone can install it? How do you make sure that this program works with that other program and they don't conflict with each other? And then that's really hard, and that's not something we're taught.
Like, for example, I had maybe this is a stupid question, but when I was doing the code, I was naming variables, and I was thinking, maybe there's like this variables repeated plenty of times in other parts of the code, and I don't know if I'm naming the same variables, but that doesn't matter, right?
Yeah, if it's inside a function, it doesn't matter.
Okay. Then okay, that's fine. I don't know how the whole thing connects to each other. So it must be fine, because if not, then you would have given a set of variables that have already been named. And well, I know functions do have to have a different name, correct?
Yeah.
Because you're calling them differently. And then to change the names of the functions is inside it. That's what you're saying is it's easier than the outside of it, correct?
Mm-hmm.
Okay. Well, interesting. Yeah, tomorrow we're going to do more Verde stuff that we last week we started introducing Verde to the Geolatinas coding group, using the tutorial that you made in Transform 2020. And it's so widely used. I mean, you can use it for very different types of data sets. That's what I meant. And we have members from all types of fields. And so we're going to continue on that. And I had the task this week of comparing the minimum curvature. What did you say, Agustina, that it was? I forgot. Oh, the blanket. The blanket.
Yeah.
The blanket.
Sorry for the example.
But it was so right. It's so on point. Because we've been using minimum curvature forever. And when I started seeing Verde's, using the scikit test train and the spline, and I was like, interesting. But I'm scared of using it with, right now, it's like 460,000 data points. So I don't know if my computer is going to blow up.
You need a lot of RAM for that.
Okay, that's why I haven't. I'm organizing the data now, because it's in an ASCII text file that's also super messed up. But the idea is to compare the minimum curvature interpolation with the Verde output. So that's going to be an interesting.
Mm-hmm.
And
what kind of data is it?
Yeah.
Sorry. Go ahead,
I was about to ask the same question.
Marine gravity data.
Okay. You can use equivalent layers for that.
Yes.
Because it's more well suited to that task, to that type of data, because you will be sure that you will get an harmonic function.
Yeah.
And also you will be sure that you're taking into account the height of the observation. So probably if it's on a boat, you can practically neglect it. But if you're making ground surveys or airborne surveys where the plane changes flight level, you need to take into account the change of the gravity value that you measure because of the height you measured at.
Yeah.
So equivalent layers are really good to produce harmonic fields that also take into account the observation height.
Yeah.
I will copy you because we have on the Transform 2020 I presented a lightning talk with a quick notebook about how to grid data with equivalent layers in Harmonica. So I will copy the link to that notebook here.
Great. Yeah, so then if I were to grid bathymetry, for example, it wouldn't be, it would probably be better with Verde, or yeah, just because, and magnetics is the same. It would be better for equivalent layer.
Yeah.
Then okay, that's why Agustina she sent in a chat, like if you're trying to grab mag data, it's better to do that. Okay.
Yeah, so the underlying math is exactly the same. So the thing that the spline does and the equivalent layer does, it's almost exactly the same. The only thing that changes is the function we use to do the modeling. So the nice thing with the equivalent layer,
Go ahead.
so I was just gonna add that the nice thing with the equivalent layer is that in Verde, so there's no z coordinate anywhere. So you're just calculating based on the horizontal coordinates, and you're producing a grid with no z coordinate defined. So if you use an equivalent layer, you can specify which z coordinate you want as well. So in one go, when you fit the equivalent layer, you can get your data with the layer. You could make, for example, a grid at a constant height. You could make a grid at a higher height, or you could even predict it on any sort of point. So you could, for example, make a grid that drapes the topography. Or you could, with the same layer, you can fit with airborne, ground, and satellite data on the same grid, and then predict at one constant height. Or basically anywhere you want, you could predict the data. So you can do... In one go, you can do derivatives, you can do leveling, you can do upward continuation. Once you have the layer fit, everything else is pretty quick to do.
Awesome. I didn't know that was also in a one or part of the package as well. Yeah, I'll definitely start looking into that. That's great. That's the sort of thing that we always try to do. Marine data. Oh, my question was, the equivalent source. Do you do the You can do the resampling. Is that useful, or you can just put all the samples in their irregularly spaced intervals?
It depends on your data. So, for example, if you have airborne data when you have so many points along the flight lines, you have like an isotropic distribution of your data. So that could introduce some aliases, because you will put a lot of sources along the flight lines and very few ones across. So in that case, yeah, I would totally recommend you to downsample it. We had Verde has the block reduce function to do so you can do it very quickly. But if you have some scattered ground data and not so many points, just use them all. Like, don't worry about downsampling.
Okay. Yeah, that marine data is always very oversampled. The gravity meter collects samples at 1 second, right? So it's very oversampled. So that's what something Reduce really. I would like to use it for both Verde and the equivalent source. So cool.
Yeah, so the equivalent source in Harmonica is made to be used together with some of the Verde tools. So you can use the Verde block mean, for example, to downsample the data to your desired grid spacing and then fit the equivalent layer on that. So basically, when you're anywhere in the Verde documentation that you're using a spline, you could substitute that for EQL harmonic, and it should work almost the same.
Okay. Great. Yeah.
Yeah, if it doesn't, let us know. It should work.
I'll definitely those are my tasks for it was going to be for this week, but I got distracted with SEG. But next week definitely it's so hard to get the raw data in to any Python code. If your data is just a mess, it's so hard. Especially with a big data set. So that's what I'm struggling right now. But that's not your problem. That's my problem.
Well, actually, I don't think I put this in the call, but I sent this on the Fatiando Slack, where I was recently playing around with some of the freely available data from Australia, from Geoscience Australia.
Yeah.
So basically, what I did there was just read in all these surveys and then try to put them all in one single file. And yeah, a lot of it was just that, trying to figure out what does the metadata mean, and how do I load this, and how am I going to put all this together. But I was doing that using netcdf. So and this is for point data, it's not for gridded data. And that works really well. netcdf is pretty fast. It has very decent compression. And it's an open standard, so tools like Xarray and Python can read it, but also GMT can read it, and a lot of other tools can read it.
We use a Global Mapper. I don't know if you've heard of that viewing software. It's pretty good. It reads netcdfs and creates them and can export whatever. But yeah, we regularly use netcdf, and Agustina helped me introduce one of our netcdfs, and the metadata and how the samples and the columns were placed were wrong. So she helped me create a grid because I was new to Xarray, and that's very useful because netcdf is very commonly used. But now we have netcdfs and Geosoft grids, which I don't understand what the actual grid, because when you open it up in an ASCII, it's like binary or something, and I don't understand what the format is. That's what I'm saying. I don't know if any of these Python packages would.
The problem, I mean, on Software Underground, they had this discussion a while ago.
Oh, really?
2 months ago. Yeah. For example, you have on Harmonica function to load the Surfer grids, the grids exported by the Surfer software, as ASCII files. You can open them with Harmonica. But someone was asking about opening the binary grids of Surfer. And I don't remember the package, but there was a package that you can use to do so that has a function to open binary files. And they could code that function because Surfer releases the format of the binary file. So a binary file basically is 101010, and they just need to provide you what the first 1010 means, and the next one, what does it mean, and how long they are, and that specification. So
is that a separate file? Like Geosoft puts out a grid and then puts out two different files. The GI file, which has all of the information that is not built into the GRD, is like a separate one, and then there's another one.
Okay, yes and no. Probably that other file is just like a metadata file, but doesn't involve that it has all the information to actually be able to read the binary file. So the thing is that Surfer puts the blueprints of their binary files, but Geosoft doesn't. So we should, in order to read that, we would need to make like reverse engineering of those files, which is not. I mean, for science, I wouldn't do that, because I wouldn't rely on a function for science that is reverse engineered. So
When I work with this type of data, thank God I don't do that anymore. In general, I save the Geosoft data in the format for open with Surfer, the grid, and save the grid on Surfers in something XTX or ACVC, and then transform that in a Python or an RxRI or something like that to use. I do these 3 steps because my ex-director work with my ex-advisor work with Geosoft, so I need to do that because the information is in this format, horrible format.
Yeah.
So I need to do that and open a virtual machine to do, because I don't have Windows.
Oh, también.
So
Yeah.
this is thank God I don't do that anymore.
Good for you. That's awesome. I have to deliver Geosoft grids to clients that don't understand that they don't make any sense. But yeah, that's the issue. I think once I try to apply all of these, like have an output as an equivalent source, then my job is to then transform it import it into Geosoft somehow, so I can get their grid format and make a grid Geosoft database with it. But that's, maybe it's one of those steps that Agustina had to do. And
if you have the information in Geosoft and you can save in surfers, and when surfer transform in TXT or something like that, maybe we can help you to make a function to transform that in XRI format. It's in only one line. You can read the information and have all the information in XRI and in a format that you can use with
nice.
any package of Python.
So one question: can Geosoft read NetCDF grids? So if you have a NetCDF grid, can you read it into?
I don't know.
I think that Geosoft can't read the last.
No.
Sí. La última vez que lo usé no se podía.
No, we have to save it as like another type of CDF for it to load. So that other type of CDF is the one that I sent you, Agustina, that was like, that didn't have any of the information. It only had the columns and rows, and that's it. And so there's another file format that's not
don't have the information of the area when you work. You only have the nodes, so you need to read that and transform and generate the latitude and longitudinal.
Yeah.
Yeah,
I think there has to be a common conversation on how to agree with these common formats. I hope that's something that the community is interested in. And I don't.
So
I haven't been in Swung enough to know about the conversation.
So that sort of stuff is what. Have you heard of a tool called Goodall or GDAL?
Mm-hmm.
So it's basically a tool that can read almost anything in and then output almost anything as well. So, for example, it can read GeoTIFF, it can read NetCDF, it can read the Esri ArcGIS grid format, and it can save. It can even save to Surfer ASCII and binary files. and it can read and write to Surfer, ASCII, and binary files. What I was checking is if it can read Geosoft files. But if Geosoft can read a Surfer grid, then you can use GDAL to convert from NetCDF to Surfer, and then you can read the Surfer grid into Geosoft. Or there's a Python wrapper as well for GDAL, so you might be able to do it all within your Python program.
Nice. Okay. Yeah, that's probably the last part of it would be using this tool to transform into whatever is needed. So GDAL, just like GDAL, no?
Yep, I'll put a link in the chat here. So yeah, GDAL.
Great.
So it can read in a bunch of raster files, and the list is huge. And it can also read vector files.
Nice. Raster graphics, geotiffs. Nice. Great. Thank you for all of the great recommendations. I don't know how long this is, but I think I have to go back. But my final question is how can I help? How can I keep contributing? Maybe not with direct code, which I would love to, but I'm learning. I'm slowly learning. But like, for example, data sets, examples, documentation, I would like to contribute maybe in those ways. Where do you need help in?
Everywhere.
That's overwhelming, Leo. That's like, I don't know where to start. I like the fact that there's first issues labeled. That's great. If you're listening, go and look at the first issues and don't be afraid. And you've labeled other things as well. But like, other than the actual code, what does Fatiando need?
Yeah, go ahead, Santi.
Yeah, no, mainly I think Harmonica is in like early stages so far, so we are changing stuff on the go. But for example, Verde, that has his first release a while ago. For example, we were discussing this week that it might need to fresh up the documentation, because when we code something, we add some documentation to it beside the doctrines, like an example or maybe a documentation page on like a tutorial on how to use it. But after you make, I don't know, several commits, your documentation is just a bunch of separate tutorials that explain different tools, but sometimes it can be a little messy and hard to understand if you're a newcomer. So maybe someone with a fresh look that doesn't exactly know how the entire project works would be nice to if you would like, or anyone would like, to read through the documentation and point, hey, this deserves like better explanation, or maybe we can order these things a little bit differently. So you don't need any code like software development skill to do so. Just running the examples, reading through it, seeing if you understand it, or if there is a better way to explain it, maybe add some figures or like that.
If you're a good writer and communicator, or organizing this is the hard part.
Yeah, I think I'm a better organizer than communicator, because my Spanglish is horrible. I say stuff in English and in Spanglish all the time.
No one is English native here.
Yeah.
So.
And the prize with the worst English is mine.
No, I don't know, not at all, Agustina. I don't know if we can say this in live, but I'd like to mention the NumPy town hall that we had. That was fun. But yeah, another conversation. Yeah, that's definitely very interesting to contribute and look at the documentation. I think that a lot of people underestimate what a newcomer can bring, because you're right, maybe the newcomer has a different view of like, well, I would like to see this, like, what about this in the documentation? So maybe I can contribute to that and say and come up with images. I would like to also test the examples that are, I tested the harmonica ones, maybe more of the Verde ones. I've only done the one for the tutorial that was there for the Transform 2020, but I can test others as well.
And even stuff like that, right? So if you're working on anything that you can share, so for example, you're trying to use Verde in this particular data set that you have. If you're writing a Jupyter notebook for that, if you can share that, one of the things we want to do is have a repository that's kind of like just a bunch of Jupyter notebooks that people contribute with real use cases. So that sort of stuff is really useful. So in the shared notes here regarding the documentation, there is a link to a page called Divio, and this is what they propose, like a structure for documentation. So how to write it, how to structure things, divided into tutorials, explanations, and so on. And NumPy recently got a big grant to redo their entire documentation in this format. And it seems like it's a really great format, and that's kind of what we are aiming for with Verde, to try to re-identify or sort of remake our documentation following this particular format.
Okay. Yeah, the format that NumPy has is very extensive. It's very detailed. They've done a really good job. In the town hall, we mentioned that there was people from SciPy and Matplotlib that have been making videos of more videos than documentation, and that was something that the NumPy team is now interested in, just making more tutorial videos. And I think it works because the documentation is a little heavy to read, especially for NumPy, and it works for people from different backgrounds. You know, when you look at a screen, you know what they're doing, where the cursor is going, versus or someone that is not native speaker in English, they can see the example itself, and they do a good job in translating the documentation. But again, you're translating functions that are written in English. So it becomes, if you're translating in Spanish, it becomes a Spanglish, like, you know, how we talk in the coding group. You forquea, to push, it's all English. So I think for the documentation, it looks like the NumPy team is on board with like having more videos and stuff like that may be helpful, of like a recording of you doing a equivalent source, for example.
That sort of stuff we really want. That's why we have this YouTube channel now, and we're very open and permissive with giving people permission to post stuff. So if you or anyone is interested in making like even a short video, just like, oh, I'm gonna run this one thing, and it could be in Portuguese, Spanish, English, or whatever language you want. But if anyone from Gelatinas is interested in doing that,
great.
Particularly like as a user, recording your screen, running through some code with your data set, that's somewhat accessible, and it doesn't matter if it's in Spanish or English or Portuguese. That would be great, and we would love to host it on the YouTube channel and spread it as far as we can.
That's awesome. Yeah, that's a good idea. Once I figure out how to do something, maybe I can repeat the process of recording it. In Geolatinos, in our coding group, we do it live. So half of our time is just debugging and why doesn't this work? And my screen is in black. And so it's live. It's all live. And we all try to help each other. And, you know, that sort of thing is not, maybe people are interested in recording the bugs and the faults. So then people are less scared of learning how to contribute or something like that. But I understand that the tutorials you have to get to a point, no? So you can't.
Yeah. But even then, I think there's a lot of value to doing things live instead of scripting it too much, because you learn quite a bit from looking at someone see an error and then figure out from the error what that means.
Yeah.
So when I'm teaching, I find that the students a lot of times they benefit a lot from me getting the error and then saying, oh, this is this error. So look at this line. This line has the information we need. When they say this, this is what that means, and this is where you should go to find the error. So the error is in this line, and that error says that, oh, I made a typo here, right? And that sort of stuff we learn from experience, from just getting these errors all the time.
Yeah. Or copying and pasting the error in Google.
Yeah.
Like, what does this mean? Yeah, for sure. Even that is a learning curve. Really, programming humbles you a lot. Great. Yeah, I think with the more things I test, I guess we will have more technical conversations. But I wanted to jump into the community call because I am very aware of the stuff that you guys are doing and that you've done a great job in your documentation and helping the user and the contributor. So I really admire that from this group because it's not easy. It's a lot of work. So yeah, I really I wish that more packages had this way of communicating and contributing to their users in general. So it's definitely an example to follow. I don't know how to make other groups do that, but I'll try.
Yeah, thanks for coming. It's really it was really great. Finally putting a face to the GitHub handle and the Slack handle.
Yeah, these community calls are very useful too. So I'll try and to see if other users that have any questions. There are some, I don't know, it's just a lot of people from Brazil. Felipe Melo is another Fatiando Tierra user, and I met him at an SEG. And
cool.
Yeah, and this was 2 years ago or a year ago in San Antonio. Yeah, a year ago. And that's the second time I had heard of Fatiando. And he was sort of helping me navigate the software as well. And I don't know what he's up to. Maybe he's doing a postdoc.
He's working in industry, I think.
Oh, really?
Yeah. He recently finished his PhD with Valeria as well.
Nice. Yeah, he's a cool guy. He was helping me out. He was in Swan too, so yeah, people like him can jump into a community call to see what he's doing and if he's using any of the Fatiando stuff in his day-to-day.
Yeah, I've been trying to get the group in Rio to jump into one of these calls for quite a while now. I keep bugging them on their WhatsApp group, but so far no one has bitten. And then, but one day I'll get Valeria here as well.
Oh, that would be great. Yeah, they're very busy in their PhD, so I can understand. Okay, well, I have to go. I have to do at least some work.
All right.
But
Yeah.
Sorry. So just before we finish off, we usually pick a date for the next meeting. So what I would suggest is keeping it on Thursdays. So I would say either the 12th or the 19th of November.
Okay.
Does that work for?
I'm editing the HackMD now. But yeah, I mean, that works for me. It's sort of, my schedules are built the week before, so